All right, so today we're going to dig into this huge contradiction that's right at the heart of AI. We have these models that are so powerful. People are throwing around terms like AGI, and yet they can completely fail at tasks that are, honestly, just dead simple for any human. We're going to explore this massive blind spot, especially when you get into subjective stuff, like what makes an image look good. So yeah, let's get right into it.
And this quote from Diego Rodriguez really just nails it. I mean, think about it. We see AI passing medical exams, writing incredible code, but then it gets completely tripped up by a question that you or I could answer without even thinking. It's just completely stumped. So what is this super simple question?
Okay, get a load of this. In AI was shown this, let's be honest, this is a horribly drawn hand, right? And instead of having that instant human reaction of like, whoa, what is that? It actually sat there for 17 seconds, running all these complex calculations, only to come back and say the image was mostly natural. Mostly natural. We see this six-fingered nightmare, and the super intelligent AI sees something that's pretty much okay. And figuring out why that happens, well, that's how we find the biggest blind spot in AI today.
Now, it's easy to just write this off as, a random glitch, a bug in the code. But it's not. This problem goes way deeper. It's actually tied directly to our own human history, how we've handled data, and even our own biology. It turns out the stuff we're teaching these AIs with, it's not as clean or objective as you might think.
Yeah, the whole story really starts way back in 1948 with a guy named Claude Shannon, basically the father of information theory. His ideas set the stage for, everything digital. Then you fast forward to 1992, and we get the JPEG. And the JPEG is clever. It's built from the ground up to save space by tricking our eyes. And now, today, our AIs are learning from literally billions of these compressed images scraped from the internet. So they're learning from a world of data that already has all of our human quirks and shortcuts baked right into it.
And if you want to see what I mean by perceptual shortcuts, just look at this classic illusion. Seriously, take a look. Are squares A and B the same shade of gray? Your brain is screaming, no way. But they are. They're exactly the same. It feels impossible, right? That's because our brain is constantly adjusting what we see based on context, like that shadow. The point is, what we see isn't pure reality. It's an interpretation.
And that little illusion, that's basically the secret sauce behind JPEG compression. See, the format is designed knowing that our eyes care way more about brightness than they do about color. So it splits the image into brightness and color, and then it just throws away a massive chunk of the color data. The final file can be like 50% smaller, but to us it looks identical. We've literally thrown information in the trash, and our own eyes can't even tell.
So this is the really critical question, right? If the internet is the giant textbook that we're using to teach our AI, and that textbook is filled with images that have been squished and altered based on our human biological blind spots, are we accidentally programming our own flaws directly into these AIs? And that leads us to an even bigger problem. Because if our data is flawed, that means the way we're measuring AI success is probably flawed too. The very yardstick we're using to say this AI is good or this one is bad, well, it's totally out of sync with how we humans actually see and value things.
Okay, so in the world of AI image generation, there's this metric everyone uses called the FID score, Freshet Inception Distance. You don't need to remember the name. All you need to know is that it's supposed to tell you how realistic an image is. The lower the score, the better the image. It's pretty much the gold standard.
So, about that gold standard, check this out. Researchers did an experiment where they took 4 photos of a dog. Now, to you and me, these look pretty much exactly the same. But because of tiny, invisible little leftovers from that JPEG compression we talked about, the FID score just goes through the roof. It basically yells, "These are terrible, unrealistic images." The metric is freaking out over digital dust that we literally cannot see.
And it gets so much worse when you step outside of just pure realism. I mean, what about art? What about this? A metric that's obsessed with photorealism would look at this incredible surrealist painting and say, nope, that's a bad image. It failed. But is it bad? Of course not. It's because the metric has zero understanding of things like creativity or style or what the artist was trying to say. We are completely measuring the wrong thing. To really wrap our heads around the scale of what the AI world might be getting wrong here, there's this fantastic analogy I want to share. It's all about the difference between predicting the thing itself and predicting what happens because of the thing. I love this quote. Predicting the car is not that hard. You know what's hard to predict? Traffic. And it makes so much sense, right? If you're living in a world of horses and buggies, imagining a carriage without a horse,
That's not a huge leap, but trying to predict traffic jams and suburbs and pollution and how our entire society would be rebuilt around this invention, that's the impossible part.
And honestly, that feels exactly like where the AI industry is right now. Everyone is completely obsessed with building the next car, a bigger, faster, more powerful model. But almost no one is thinking about the traffic. We're not building the right tools, the right measurements, or even the right way of thinking to handle the enormous societal and cultural impact of what's coming.
Okay, so I know that all sounds a little grim, but here's the really fascinating, optimistic twist. The solution to this huge gap in AI's understanding might just be more AI. We can actually use the technology's own incredible strengths to teach it how to see the world more like we do.
Think about the old story of the Tower of Babel, where everyone suddenly spoke different languages and couldn't work together anymore. For pretty much all of human history, that's been our reality. But right now, AI is basically solving language translation. We are walking into an era where language is just not the barrier it used to be, which is kind of amazing.
And look, this isn't science fiction. It is happening today. This is from a real person who does customer support. They're talking to users in Japan, perfectly, in Japanese, but they don't speak a word of Japanese themselves. See, the AI isn't just swapping words. It's translating intent and nuance. It's bridging that deep human communication gap.
Okay, so if AI can become this incredible universal translator for complex, subjective human stuff, how do we turn that power back on itself? How can we use that ability to finally build a better way to measure AI's own success?
Well, the path forward means we need a whole new set of tools. We have to stop using broken metrics like FID and start training these models directly on what we actually care about. Human preference, what we think looks good. We need to build AIs that know our data is messy and full of things like JPEG artifacts. The bottom line is, we have to create new ways of measuring that embrace subjectivity, not try to pretend it doesn't exist.
And this really brings us to the final amazing insight. You know that fuzzy, subjective feeling of, I can't really explain it, but I know it when I see it? That feeling that defines art and beauty and taste? Well, it turns out that is exactly the kind of messy, human problem that modern AI is incredible at learning. We can actually teach it our opinions. We can teach it what we like. So as we start building these new kinds of AIs, ones that are perceptually aware and understand not just pixels, but human meaning, it leaves us with this incredible, exciting question. Once AI really learns to see the world through our eyes, what are we going to ask it to create for us next?